So basically today we are going to be talking about hyperbolic functions. Okay, so these hyperbolic functions, we must know that whenever we talk of hyperbolic functions, we are talking of combinations of exponential functions. So we are talking of combinations of exponential functions, e and e to the power negative x. Okay, we are talking of e and e to the power negative x. All right. So frequently in mathematics and its application, they deserve to be given special names. All right. So from the notes which I gave you can go through that. So basically, what we are talking of hyperbolic functions is you must know that sine x is equal to sine h. Sine h x, not sine x, sine h x. Sine h x is equals to e to the power x minus e to the power negative x, okay, over 2, and then which means these are the definitions which we must know from exponential functions. All right, and then we are going to show you how we came to find these functions. How did we find that sine hx is equals to that? So this is just a summary of the table. All right, so we know that cos hx, cos x is equals to e to the power x plus e to the power negative x over 2. And also similarly, we have tan x. And remember, tan x is sin hx over cos x. Okay, and then cosec hx, it's 1 over sin hx, you must know that, and secant hx, it's 1 over cos hx, and cot hx is cos x over sin hx. Okay guys, right, so basically we are moving there. So we have two graphs which we have, how we came to find what is cos x, tan hx. So we have two exponential graphs here. We have this graph which is y is equals to e to the power negative x. All right, and we have this graph also which is going upwards, which is y is equals to half e to the power x. It's a positive one, which means if it's reflected in the x, you see the reflection there. This is the graph. So it has been reflected in the y, not in the x. So it's the graph of half e to the power x has been reflected in the y to obtain this graph. So if we add these two y's, we are going to get this cos x. All right, and then this one is the graph of tan hx. All right, which is on our right hand side, tan hx. So tan hx, what is tan hx? Which means it has an asymptote here, meaning that there is no value for when you plug in 1. Tan h1 is undefined. All right, so we can say 1. If you put 0 here, we know it's 0. Okay, but for us to get a value when y is equals to 1, there is no value that we are going to get here. All right, that is an asymptote, so we must know the sketch. So basically it means that y is equals to cos x minus half e to the power x plus half e to the power negative x. This is the definition of cos x. You must know it because it's two. It's hyperbolic, involves addition of graphs. So we are adding this graph plus that graph to obtain a hyperbolic graph. Okay, so we must know the sketch of a tan h graph, and also you must know the sketch of cos x graph. Okay, all right, we are moving on. So those are the, I want to show you the graph of I did not show you the graph of signage x. Signage x. All right, there we go. Signage x. I must show you the graph of signage x. All right, so the graph of signage x, it involves the graph of signage x, it involves addition of these two graphs. So we have the graph of y equals to half, which is this one, and then we have the graph of y is equals to negative half e to the power negative x. So what you must know here is that this graph, first you reflect half e to the power x along the y-axis, you obtain this graph when you reflect it along the y. You reflect this graph of y is equals to half e to the power negative x along the x-axis, you are going to obtain this graph. Okay, so this is y is equals to negative half e to the power negative x. Like I've told you, when we are dealing with hyperbolic graphs, we mean we are adding graphs. All right, so we are going to add these two graphs to obtain a hyperbolic graph. Which two graphs are we going to add? We are going to add this graph, okay, and then plus this graph, the second one. All right, so which means that y is equals to sine hx. It implies that is equals to half e to the power x plus this one. So a plus and a negative, it gives you negative. So we did not subtract, but we added a negative. So a plus negative just give you a negative. So hyperbolic means we are adding graphs. All right, the same applies with the cos, which I've just mentioned earlier before. All right, we move on to the next slide there, next page. All right, class, so which we mean that on this one we are dealing with identities. So you must know that hyperbolic functions satisfy a number of identities that are similar to well-known trigonometric identities. We list them here and leave most of the proofs to the exercises. Okay, so let's start. So signage negative x here is equals to negative sine hx. All right, cos h negative x is equals to cos hx. So this you must know it by heart, that this is it means that it's an odd function, this is an even function for cos. And unlike trig function for cos, remember you see there's a negative in between, which implies that cos x squared minus sin hx squared is equals to 1. And these are the identities that you must know, class. You must know them by heart. Okay, we move on to the next question. So in this example, it's saying prove that cos h squared x minus sin h squared x is equals to negative 1, and b 1 minus tan h squared is equals to secant h squared x. So basically you start by defining what is it that you know when it comes to cos squared x, okay, minus sin h x squared x, okay, sin h. All right, so cos squared x minus sin h squared x, you define, put everything inside the bracket. So it's e to the power x plus e to the power negative x over 2. Remember, cos squared, it means everything in the bracket squared. You subtract e to the power x minus e to the power negative x. This is for sine hx squared. Then you square the bracket. All right. You simplify the like terms together. When you square, remember laws of exponents says when you square the 2, you multiply there with the 2. Okay. And also here, you square a 2, everything is squared. Remember the denominator squared. Also here, 2 squared, okay, and also negative 2 squared. Right, don't forget that where did the 2 come from? This 2, where did it come from? Okay, remember it's 2 of the halves. All right, when you square that first term, last term, all right, plus 2 of the halves. All right, so that's where therefore the 2 is coming from. All right, 2 of this times that. So it's this squared, that term squared, plus 2 that by that. So this by that is going to give you 1, because x plus minus x is 0. So 2 times 1 is 2. That's where it's coming from. Okay. Similarly with that one. All right. So when you simplify everything, it's going to give you 1. So basically what we are doing here, we are just using the definition of what we are given from the beginning. What is cos squared x and what is sin h squared? We are just plugging in there. There shouldn't be any difficulties. Okay. If we divide both sides of cos x squared, we get what? All right, let's divide. So cos x squared divided by cos x squared. So we are going to get 1. All right, and then that one it will be 1 minus sin h squared x minus, you divide it by cos squared x is going to give you 1 over cos squared x. So we are dividing both sides by cos squared x. So we are going to get 1. This will be tan. All right, and then 1 divided by cos, it's secant h. All right, class. All right, so okay, let's move on to the next example. Or we can what is they are just showing us is that when you differentiate sin hx, we are just going to get cos x. Cos x, it does not change. Another key point, these are derivatives when you are differentiating. Okay, what is the result there? All right, so here in this example, they applied chain rule. Why is it chain rule? Because it's a function of another function. You see in the square root sign here, there is no cos x. It's cos square root of x. So that square root is another function again. So we must differentiate with that function. That is chain rule, a function of another function. So which means if I differentiate cos square root of x, I'm going to get sine square root of x. It does not change. But because that square root of x is inside a square root, it's not only x. If it was only x, we know the derivative of x is 1. So we just end there. But because the derivative is square root of x, we differentiate again this square root of x. Then it will be 1 over 2 root of x. If you differentiate the root of x, you get 1 over 2 root of x. Then this will be the final answer. Okay. So from here, we are going to go to hyperbolic, inverse hyperbolic functions. Okay. So we are going to talk of inverse hyperbolic functions. All right, so basically from here what they are saying, you can see from figures 1 and 3, signage and tonnage are one-to-one functions, and so they have an inverse function denoted by that negative. So sin h to the power negative there, it implies inverse. That negative there, -1, implies inverse. All right, so figure 2 shows that cosh is not 1 to 1, but when restricted to domain from 0 to infinity, it becomes what? 1 to 1. All right, the inverse hyperbolic function is defined by the inverse to the restricted of this restricted function. For example, y is denoted by sin h -1, which implies that sin h -1x, which implies that if you want to make x subject to the formula from here, it implies you invert, which means it's equivalent to this. Inverse, where there is y, you replace with an x. For example, y is equals to sine inverse of hx, which means the inverse of this, it will be sin h y is equals to x. All right, if we use cosh, inverse of cosh x, so this one is inverse, so inverse of cosh x and inverse of sin hx. Some books they write it as arc sine, some they say arc cos, some they say arc tan. It's still the same. So sin h y is equal to x. Now it's an inverse. So if I say y is equals to cos inverse of x, cos inverse of x is the same as saying cos y is equals to x. All right, for y greater or equal to 0. All right, so which means for y greater or equal to 0, this will be the cosh. All right, because it has a restriction. Y can't be less or equal to 0 because it becomes undefined. Remember, it will be a logarithm. And also for y is equals to inverse tan hx, is the same as saying it's equivalent to tan hy is equals to x. So these are some of the things you must familiarize yourself with. Okay, so now the remaining inverse hyperbolic functions are defined similarly. See exercise 28. All right, we are going to see this exercise. We can sketch the graphs of inverse of sin h, inverse of cos h, inverse of tan h. We can sketch them by using figures 1, 2, 3. All right, these are the figures. So this one you can see, this is y is equals to the inverse of cosh inverse of cosh x, and then this is the inverse of tan x. You must note the difference with the one that we did before and this one. Okay, so this one, it's a logarithm one, so it always starts at 1 going there. Then this is the standard of y is equals to cosh inverse of cosh x, without any shifts of left or right, up and down. The standard, it looks like this, always starts at 1 going up to infinity. Okay, so you can see that your domain is starting at 1 going to infinity, and your range is starting from 0 going up to infinity. All right, so we go to figure 9, which is the inverse of tan. So inverse of tan hx, it is a domain, so the graph is towards the y now, instead of it being towards the x. All right, like the one which I showed you previously for tan hx, not the inverse. All right, so you must note that the asymptote now is now vertical. Before, the asymptote was horizontal. It was horizontal, now it's now a vertical. All right, so domain is equal to -1 up to 1, but not including. This round bracket is different from the square bracket. When you see the domain is written with a square bracket, it means including, excluding infinity, because infinity is not a number. Infinity is not a number. Here we are excluding the asymptote. Also there we are also excluding the asymptote. So that is the standard graph of y is equals to inverse tan hx. Okay, inverse tan hx when you see, or arc tan hx, or arc cosh x. All right. So now we are talking of, since the hyperbolic functions are defined in terms of exponential functions, it's not surprising to learn that the inverse hyperbolic functions can be expressed in terms of logarithms. So in terms of logarithms, so a logarithm of base e, it means log base e is represented by log base e is represented by ln. That's why it's a logarithm, but it's a log of base e. All right, so these are the definitions. We are going to prove how we got that sin hx is equals to that, y is cosh x, inverse of sin hx equals to ln that, and y is inverse of cosh x equals to that, and y is inverse of tan hx equals to that. So we are going to prove it, although you must know it by heart, but you do not have to cram or to memorize. You must be able to prove how you got these values. Okay, so we are going to show that the sin h of x, which is that one, is equals to that. So now we want to show it using the basics knowledge that we have. We know now. So first we are going to say let y equals to sin hx. All right, so y is equals to the inverse of sin hx. So this is an inverse hyperbolic function, that is y. So you want to put y to look like ln x plus root of x squared plus 1. So that is our main objective here. Okay, so we are going to say, then if it means that y is the inverse of sin hx, so if I want x, what must be my y? So it simply means that you where there is x, now you put a y, but it's no longer an inverse. This is how you rewrite this statement. So this statement can also be written as x is equals to sin hy. Okay, for example, on this table, if y is equals to sin hx, sin inverse h of x, okay, it implies that x is equals to sin hy. That is the same logic they are using here. That is the same logic that has been applied here. Okay, so using this information, we make x subject of the formula. So the only way you can make x subject of the formula is to just swap where there is x, you put a y, and then you remove this inverse. So where there is x, I put a y. Where there is x, you put a y. Where there is y, you also put an x. Then you remove the inverse, and then becomes a normal signage y. So if it's a signage y, what does it mean? It means that it's e to the power y minus e to the power negative y from the definition over 2, because all the e's are half half. The 2 is simply saying everything is half half. Okay, so e to the power y minus, so we are simplifying the numerator there. We multiply both sides by what? By 2. And what are we going to get? So e to the power y minus 2x minus e to the power y. Where did this come from? So from this equation, you equate it to 0. What happened? X is equals to what? If you say x is equals to that, all right? So you can multiply by e to the power y. For example, e to the power 2y minus 2x e to the power y minus 1 is equals to 0. In other words, x is on your left hand side, and then you multiply everything by 2. All right? So from here, once you push everything to the left hand side, so you are pushing, remember your x is equals to signage y, and your x is equals to e to the power y minus e to the power negative y over 2. That is my x. Okay, so when I move everything to the left, which means I move this to the left hand side, then it becomes what? All right, or either you move x to the right hand side. If you move it to the right hand side, then you multiply by 2. So which means when x comes to the right hand side, it becomes negative x. Negative x times that 2, want to remove the denominator, it becomes e to the power y minus 2x minus e to the power negative y is equals to 0. Okay, and then here, which is the same thing, whereby they just multiply by e to the power y. All right, so if we make it a quadratic equation in terms of e to the power y, so it becomes e to the power y bracket squared minus 2x e to the power y minus 1 is equals to 0. So you saw it is a quadratic equation. This is your a, this is your a, it will be what? It will be 1. Your b, it will be minus 2x, and then your c, it will be negative 1. Okay, so in other words, you are saying x e to the power y, that is your x, which you want to solve for. So e to the power y is equals to minus b, which means minus 2x. Okay, minus 2x, which becomes positive 2x, plus or minus square root of, what is b squared? It's b, we said it's minus 2x. All right, so b, it's that squared, which means becomes 4x squared. All right, so it's b squared minus 2ac. All right, b squared minus 4ac. So negative times negative becomes 4. Negative times negative, positive 4. A, it's 1 here. C, it's also 1. So it becomes 4. Everything over 2. Then you get e to the power x, e to the power y is equals to x plus or minus square root of that. So if it's e to the power y, so you must note that e to the power y must be greater than 0. Alright, but x minus square root of x squared plus 1 should be less than 0, because x less than that, that's the minus sign is inadmissible, and we have e to the power y is equals to x plus square root of x squared plus 1. So from this solving of e to the power y, we are going to have two solutions because it's a quadratic equation. So if we are going to have two solutions, it implies that the first solution will be x minus square root of x squared plus 1. And then the other one will be x minus square root of x squared plus 1. So which one are we going to take as our value here? Is it a positive or is it a negative? That's where we say that e to the power y has to be greater than 0.